Today we're looking at two-way tables. A two-way table displays two categories of data collected from the same source. So as you're going to see right away, we have just like one single table like we would normally see. We have this kind of student who studied or didn't study information. We also, coming from this side, have some information about their grades and if they passed or they failed, and it kind of all mixes in together. So we kind of have information about the student and their studying habits and their grades that all combine together, but in two different ways. So they kind of merge together. A little more specifically in this one, their students were surveyed in the school about their grades on the last test and whether they studied or not. The two-way table is showing their results. So the first vocabulary here we want to talk about is right here, joint frequency. Well, each of the little numbers in each of these little categories, there are the joint frequencies. Okay? When we read a two-way table, what we want to think about is how do we kind of find the point that answers both parts? And there's usually with the two-way tables, there's going to be kind of two parts to the question. So, question one is how many students in the survey above studied for the test and passed? So what we want to look for is we want to find the area where they studied, which is right here down the column, and passed. So that would be this number right here. That's where they kind of intersected. And so the answer to this question is going to be 21 students. So the sum of the rows and the columns in a two-way table are called marginal frequencies. So again, it's more vocabulary than anything else. When we talk about joint frequencies, we're talking about the individual boxes that are in there about the different things that could happen. The marginal frequencies basically add another whole column here. So when I'm looking at a marginal frequency, basically what we do is the marginal frequency is going to take this information on this row and add it together to get a total. Take the information from this row and add it together to get a total. Take the information from this column and get a total, and this column and get a total. So basically what's going to happen here is we actually end up kind of extending out a little bit further if we were doing the true two-way table. And basically our marginal frequencies are these numbers out here, because these are the totals that we are looking at. So basically as I add straight across, there would be 23 students who passed. There would be 7 students who didn't pass. There was 22 of our students who studied, and there were 8 of our students who didn't study. Now this kind of a table is not really telling us completely all the information as to specific students. It's trying to gather in the students that didn't study, didn't do so well, did study, did very well. And this last little column down up a corner box here is basically totaling straight down. 23 and 7 is 30, and it should equal the horizontal 22 and 8 equals 30. That's basically telling us the total of people that took this survey. So the marginal frequencies are when we add across. So then we want to find and interpret the marginal frequencies. Well, we kind of already added those across. Now we want to interpret them. So we first did the 23 students passed. We also had 7 students who didn't. We won't say failed, we'll say who didn't pass. Next, if we go down and add down through our columns, we had 22 students studied and we had 8 students didn't. So that would be kind of interpreting those marginal frequencies. And again, we can kind of make some good assumptions there. 23 students passed the test and 22 students studied. Pretty good indicator that those are the students that passed. And then the 8 students that didn't pass, and there were 7 students who didn't study. Again, that would probably be the correlation of that. So here we want to look at the next one. So we randomly survey some students in the cafeteria about their plans for a football game and a school dance. So here's kind of the clue: football game and a dance. So those same students, so the same sample is giving questions about 2 different things. So that's where the two-way table can show our results. So how many students will attend the dance but not the football game? Well, again, I want to use what I know about these tables. So will attend the dance is this row, but not attend the football game. Well, that would be this number right here. So they're going to the dance, not the football game. So we would answer here A is 5 students. Dance, no game. Game. On to B. Find and interpret the marginal frequencies for the survey. So I think I'm going to also right now, you should have written this down already. I'm just going to take out this information so we can kind of extend out our table. So find and interpret the marginal frequencies. So again, we want to kind of create this little extended column and row to do our totals. These are the marginal frequencies. And so again, if we add down the column for the football game, we end up with 51 students who attended the football game, 25 who did not attend. If we add across the row, we had 40 go to the dance, and we had 36 not go to the dance. Now remember, if the marginal frequencies are done correctly, when I do the totals down, I should get the same number as if I do the totals across. And this number here is going to tell me how many students we talked to. We didn't talk about that in the first part of this. We just want to make sure we talked to the same number. So we actually surveyed 76 students. So those are the marginal frequencies, and again we want to interpret what that tells us. So 40 will attend the dance. 36 will not dance. Then we look at our football. 51 will attend the game. And 25 no game. Okay, so joint frequencies are the individual numbers about each of the items. The marginal frequencies are the totals that go across and go down. So next we want to talk about making our own table. So here's what we're going to do next. So we are randomly surveying some students. Again, we don't know the number, but we will figure it out as we go. Between the ages of 12 and 17 about whether they ride the bus to school or not. So in this case, our two categories, we have ages and we have whether they ride the bus or not. You can see our tally sheets off to the side where we have a column for the ages, and we also have the rides the bus or doesn't ride the bus. So basically what's going to happen is we're going to make these kind of be our categories on the left margin, and basically whether we ride the bus or not ride the bus will be the other part of ours. So what that's going to look like is this. So age and bus. Okay? So what we need to start doing next is we're going to draw like a line here. You know what? I'm going to take that line out for the moment. I think we're going to need a little more room than that. That's not much better, is it? So we're going to do ride the bus or not ride the bus. So really those are the two choices there. Then we're going to talk about 12 to 13, 14 to 15, and 16 to 17. So here we have the ages. So just kind of filling in some of this box, we now get something that starts to look like a two-way table. So we're going to get our totals here. We're going to get our total down here. Remember, these are our marginal frequencies. And then we're just going to start plugging in our data. Okay, so when I look at the first box in the upper right left-hand corner there, we're looking for students that ride the bus that are 12 to 13 years old. Well, over here we have the ride the bus that are 12 to 13. So 5, 10, 15, 24. So 24 goes there. Next we want to talk about the next one, rides the bus 14 to 15. Well, I see 12. When I look at the next one, rides the bus 16s to 17s, we see 14. And then we would follow the same idea down here on the next one. So doesn't ride the bus, we would say the 12 to the 13s, there are 16. The next one down, the 14 to 15-year-olds, there is 13. And in the last one, there is 21. So to find my marginal frequencies, remember we add across. So I'm going to add across the rows first. We would get 40. We would get 25. We would get 35. Adding down for the bus numbers, we have 50 and 50. So now we know if I add my column and my row for the marginal frequencies, we know the number of students we happen to survey, which happen to be 100. So that's kind of how we fill in one of those tables. So what we want to do next is, and this is part of the next example, we have our we have our table. For each age group, so for each of the age groups, we want to find out the percent of the students who ride the bus to school. And then we want to know the percent of the students who do not ride the bus to school. And we're going to organize that information in another table. So when you notice the first table we made, it was all about just raw number of kids. Now we've got to start looking at information that is talking about percentages. So in this case, we're going to use the same raw data that we just had. But now we're going to kind of show here how to make a table with percentages. So I'm going to try to make this as big as I can just so that we can see this. So we're going to put our bus here. We're going to put ride, not, and then we're going to do our total over here. We have our age way out here. We said 12 to 13, 14 to 15, 16 to 17. Now in this table, I'm not actually going to do a marginal frequency column, or row in this case, for the bus bottom part for the ages. because really what we're focused on is the different age groups and what they are doing in their little rows. So in this situation, I am not doing the full all the way across total. What we're going to do is end like this. Because remember, it's talking about for each age group, find the percentage of them that are riding. So we're not looking at the bottom row that we would have on the up above with the 50 and 50 and 100. So now we got to think percent. So when I look at the 12 to 13 year olds, well, we found up here that in the 12 to 13 year olds, we had 40 students. So that's going to be my denominator for the 12 to 13 year olds. When I look at my 14 to 15 year olds, there were 25 total students. And my 35s for the 16 to 17 year olds. And that's important to keep in mind. We're finding the percent of each of the age groups. So when you look at it in those terms, students that ride the bus at 12 and 13, there was 24 of them out of 40. And then the second one, there were 16 who did not ride it out of 40 12 to 13 year olds that did ride it. So remember, how do I change that into a percent? Remember, changing into a percent, we would take 24 divided by 40 times 100. And when I do that, I end up with 60%. When I do the same thing with 16, I get 40%, which is good because if I add across the marginal, if we're in percentages, those two need to add up to 100%. On to the next one. So on the next one, remember, we did the 14 to 15 year olds, there was 25. So the denominator here is going to be the number of students out of 25. Well, in the first one, the 14 and 15 year olds, there was only 12 that rode the bus, and there were 13 that didn't ride the bus. So as percents, we are looking at 48%, and we're looking at 52%. And then added across, obviously, we need to total the 100%. And then lastly, when we look at the 16 to 17 year olds, there were 35 total in that age group. I would have 14 that still rode the bus, and we have 21 that did not. And when I do my percentages here, we get 40% and 60%, which works with 100%. And I think what we want to start looking at is when we start looking at our numbers, you first might say, well, if I looked at my first table up at the top, notice how it looks like, well, when I talk about students that ride the bus, there are way more older ones than younger ones. I mean, younger ones than older ones, and not much different in here. But when you start looking at the table part of things in percentages, you can start to really compare because now you have things that are comparing in decimal form. So you've made them common denominators, which is a better way to kind of judge how they actually compare. So does this table we created show a relationship between age and whether the students ride the bus to school? Well, I would say it's pretty clear. Yes. As students get older, they tend to ride the bus less. So again, it's not, it's not completely clear all the way through, but it seems like as they get older, they ride the bus less. So if you look at here, riding column is here and it kind of goes down. Over here, the not riding column seems to go up. It's not going to be true about every student, but it is showing that trend there. Could mean a lot of different things are happening. They obviously start getting their licenses, so they can drive themselves. And sometimes their friends get their licenses and can give them a ride. So there are less students riding the bus as they get older, to the 16 and 17-year-old age group.